Most of us have a rough idea of what our key hormones do. We know insulin manages blood sugar, cortisol is linked to stress, thyroid hormones keep energy in check, and melatonin helps regulate sleep. But there is one hormone that we might still be putting in a specific box based on what we may have learned ages ago. For a long time, my own understanding of prolactin began and ended with one thing: milk production. I learned that it was the milk hormone, essential for helping breasts grow during pregnancy and to start and maintain breast milk production after a baby is born. And that was that. But here's what started to shift my understanding. This hormone isn't just present in pregnant or breastfeeding women. It circulates in all of us, men, women, and children, throughout our entire lives, at levels that can be similar enough between genders, although they are normally significantly elevated during pregnancy and lactation. This was the first clue that the story we might know about prolactin may be incomplete. If it's always there in everyone, what else could it be doing? It turns out our bodies have been hinting at the answer all along. We now know prolactin isn't just produced in the brain. It's made in our immune cells, our fat tissue, our central nervous system, and more. And scientists have found receptors for prolactin in nearly every organ in the body. This isn't just a specialized hormone with one job. It appears to be a fundamental communicator involved in a conversation that happens across our entire system. Now, this is where the research gets particularly interesting, especially when we look at metabolism. For decades, the textbook view was that prolactin was diabetogenic, that it promoted insulin resistance. But more recent clinical and experimental work has revealed a much more nuanced picture. It seems the metabolic effect of prolactin may, at least in part, depend on its level in the body. When levels are too low, we see associations with metabolic alterations. At extremely high levels, like in certain medical conditions, it can contribute to insulin resistance and weight gain. But at stable, high normal levels, it appears to be associated with better metabolic fitness and can even play a protective role. It's a good example of how a single hormone can have different, even seemingly contradictory, effects based on its concentration and context. And this story connects to another well-known player, dopamine. Dopamine acts as the main brake on prolactin production, and this relationship is a two-way street, and both are also independently involved in regulating metabolism. So what does this all mean? It's a reminder of how complex and context-dependent our biology is. Prolactin is far more than a milk hormone. It's a key participant in immune function, metabolic balance, osmoregulation, meaning it influences water and salt balance, growth and development, brain and behavior, and even angiogenesis that has to do with the regulation of blood vessel growth. Its story challenges old categories and shows us that sometimes the most fascinating scientific discoveries come from re-examining what we thought we already knew. It feels hopeful in a way. It suggests there are likely many more layers and connections in our health waiting to be understood, not just by scientists, but also regular people with more nuance. What's one thing about health that you feel we're only just beginning to understand?